Leucippus, a Greek philosopher from the 5th century BCE, is widely credited as the first to propose the atomic theory of the universe, laying the groundwork for what would become a profound and lasting legacy in natural philosophy. He suggested that everything in existence is made up of minuscule, indivisible particles called atoms, from the Greek word atomos, meaning uncuttable or indivisible, and that there exists a void in which these atoms move freely. Although little is known about his life and works, Leucippus's atomic theory was advanced and expanded by his student Democritus, who became more widely recognized for the atomic model. Together they put forth a bold and innovative idea that the universe is composed solely of atoms and void. They suggested that all changes and transformations in the world are a result of the movement, combination, and separation of these tiny particles. This was a revolutionary notion in ancient Greek thought, challenging the prevailing monistic views held by philosophers like Parmenides, who argued against the existence of both the void and multiplicity. In the atomic theory of Leucippus and Democritus, atoms were seen as eternal, immutable, and indivisible. The two thinkers believed that atoms come in various shapes and sizes, which determine their properties and behaviors. According to this view, all matter and phenomena, from the physical objects we see to human consciousness itself, were explained as configurations and motions of these atoms. Unlike later atomic theories, Leucippus's idea lacked empirical validation but relied heavily on logical speculation and reasoning. Nonetheless, it offered a remarkable explanation for phenomena such as change, decay, and transformation, providing a naturalistic account for events that others attributed to divine forces or mystical properties. Leucippus's theory also introduced the concept of a vacuum or void, a notion that was controversial and fiercely debated among Greek thinkers. Parmenides and his followers argued that a void was an impossibility, as nothing could not exist. However, Leucippus claimed that without a void, motion would be impossible, as atoms would have no space to move or interact. By suggesting that atoms moved in a vacuum, he laid the foundation for a new understanding of movement, space, and interaction in a material world. The atomic model of Leucippus and Democritus remained influential, as it addressed complex issues about the nature of reality, structure, and change in ways that were remarkably forward-thinking for their time. Leucippus's ideas, though often overshadowed by his more well-documented student Democritus, are a cornerstone of the history of science. They provided an alternative to mythological explanations and steered ancient philosophy toward a rational understanding of the cosmos. The atomic theory eventually faded from prominence until it was revived many centuries later by thinkers like Galileo, Descartes, and Newton, whose work laid the groundwork for modern atomic theory. Today, Leucippus's ideas may seem primitive compared to our current understanding of the atomic structure, quantum mechanics, and particle physics. Yet, the core principles of his atomic theory resonate with modern scientific views, affirming the notion that the material world is composed of fundamental particles and interactions. Thus, Leucippus's contributions, while surviving only in fragments and indirect references, mark a significant moment in the development of scientific thought. His daring inquiry into the nature of matter, motion, and space opened up new avenues for future philosophers and scientists. By proposing that everything in the universe has a material basis, and that all transformations arise from the interaction of indivisible particles, Leucippus set a precedent for scientific inquiry grounded in observation, logic, and rational deduction, principles that remain at the heart of scientific exploration today.